Welcome back to MLT 115. Today we're going to do some problems relating to or dealing with significant figures. Significant figures are covered in the lecture of basic mathematics. The first thing we're going to do is we're going to look over the rules of significant figures real quick. We covered this in the lecture, but let's look at these rules again real quick. All non-zero numbers are considered significant. So these would be your 1, 2, 3, 4, 5, and so on. Numbers or zeros to the right of non-zero numbers are significant on either side of the decimal. Okay, and we looked at some examples of that in the lecture video. Zeros to the right of the decimal point are not significant if there's no non-zero number to the left. And then finally, zeros between non-zero numbers are always significant. So let's look at several examples. These are from page 23 in your textbook. So let's read our directions. We're going to be rounding off the following values and express them in three significant figures. So let's look at number 41 first. So 41, it gives us 1.754. And they want us to decide what's three significant figures of that number. Well, we know from our significant figure rules that all non-zero numbers are significant. So if we're doing three significant figures of that number, all we would need is 1.75. And we don't have to round up because the last number is 4. So we'd end up with our answer is 1.75. Now let's look at our next problem. Problem 42. We've got 0.86237. Again, we're trying to get it down to three significant figures. So again, all our non-zero numbers are going to be significant. But this 0 before our decimal point is going to be non-significant. It's basically just a placeholder. So our three significant figures is going to be our 8, our 6, and our 2. So if we're trying to write out three significant figures, we can just put the 0 there basically for a placeholder. And then we'll put 8, 6, and 2. So that's our answer. Okay, 43. We've got 0.001747. And this is a little bit a different scenario where we have zeros on the right side of the decimal point, where we only had a 0 to the left of the decimal point before. But this was one of our rules that we went over. Zeros to the right of the decimal point are non-significant if there's no non-zero number to the left of it. And that's the situation. So this number is just like a placeholder. That's in the same scenario as 42. And because these two zeros do not have a number that's non-significant in front of it, they're insignificant as well. So really our significant numbers are going to be our 1, our 7, and our 4. So really when we're writing our significant figures out to at least three significant figures, our answer is going to be 0, just because that's a placeholder. And we're going to have to write these two, even though they're not significant. Again, they're going to act kind of as placeholders as well. And then it's going to be 1, 7, and because this we have a 7 here, we're going to have to round up to a 5. So this is our answer, 0.00175. Now let's look at 44. We have 100.96. This is a different scenario. We have a non-zero number to the left of our zeros. So that's going to make our zeros significant. So we're trying to get down to 3 significant figures. Our 1 is now going to be significant. And because that 1 is to the left of those 2 zeros, now those zeros can also be significant. And our answer is going to be 101 because of that 9 is going to round it up to 101. So our 3 significant figures is 101. In problem 45, we have 1,531.2. And again, we're trying to round to 3 significant figures. Well, we don't have any zeros to have to worry about. So our first 3 numbers are going to be our significant numbers. We're going to have 1, 5, and 3 that are going to be significant. Well, we can't forget that we're dealing with a number that's in the thousands. So something has to be a placeholder in that last position. So because we're not rounding up, it can't go up because of this 2. We're not going to round up. So that 1 is just going to become a 0. So it'll be 1, 5, 3, 0. So it's 1,530 is going to be our answer. Because we couldn't leave it 153 because that's a totally different number. Yeah, the 1, the 5, and the 3 is our significant numbers, but we have to have that that 0 as a placeholder. For 46, we've got 0.0115. We've got zeros to the left, both on the right and to the left of the decimal. But those numbers are both not going to be significant because we don't have any non-zero numbers in front of them. So our 3 significant figures are going to be our 1 and our 1 and our 5. So that's our 3 significant figures. So when we're writing the number out, we have to still include those zeros because those are our placeholders, but they're not significant. So our answer is still going to be 0.0115. And again, those zeros are just placeholders, but they're not significant. 47, we've got 0.0125. Very similar situation. We have zeros at the beginning on both sides of the decimal, but we don't have a non-zero number in front of them. We're to the left. So again, our 3 significant figures are going to be the 1, the 2, and the 5. So when we rewrite it out, the zeros are going to be placeholders, and our significant figures are going to be the 1, the 2, and the 5. So that's going to be our answer. Now we have problem 48. We have 124.7. All these are significant, non-zero numbers. So we're looking for the 3 that are significant. So we're trying to round off to 3 significant figures. So our 1 is going to be significant, our 2 is going to be significant, and our 4 is going to be significant. But we have a 7 here, so we're going to end up rounding our 4 up to 5. So our answer is going to be 125 for our 3 significant figures. All right, 49. We've got 1, 1, 1, 1. Just make sure I get all my ones in here. We don't have any decimals, so this is going to be one of those situations where we're going to have zeros at the end for placeholders. We don't have any zeros in the number. We don't have any decimals. So our first 3 numbers, first 3 non-zero numbers are going to be our significant numbers. So our first 3 ones are going to be our significant numbers. Oops. So when we rewrite it, the last numbers, we're going to switch to zeros because those, like I said, are going to be more like placeholders. So 1, comma 1, 1, and the rest of these are just going to be placeholders. So 1,110,000 is going to be our final answer. And then for 50, we've got 0.0000999. Now we've got a lot of zeros here, but we don't have a non-zero number to the left in front of those zeros. And again, we have both zeros on both sides of the decimal. So our last 3 nines are going to be our significant figures. And these zeros are just going to be placeholders. So 0.000, they're just going to be holding place for us. And then our 999 is going to be our significant figures. Now that we've worked all the problems trying to find 3 significant figures, let's change it up a little bit and work a couple of the problems. And since it's 3 significant figures, let's do 2 significant figures, just for illustration purposes. Let's go back and do 41, but let's only do 2 significant figures. So 1, 7, 5, 4. And we're only looking for 2 significant figures. So our first 2 numbers are going to be our significant figures, because those are both non-zero numbers. Well, now our 5 will make our 7 round up to 8. So our final answer is going to be 1.8. Okay. Now let's do 43. And let's do 2 significant figures. So if we rewrite 43, 0.001747. Again, we're trying to do 2 significant figures. Those first zeros are going to just be placeholders because we don't have any non-zero number to the left of those zeros, even though we have zeros on both sides of the decimal. So 2 significant figures are going to be our 1 and our 7. So when we rewrite our answer, we're going to use these zeros as placeholders. So it's 0.00, and it's going to be 1, 7. Then we have a 4 here, so there's no need to round up. So that'd be 2 significant figures for that number. Let's do 47. 2 significant figures. 0.0125. Again, these zeros are not going to be significant because we don't have any non-zero numbers in front of them. So these zeros are going to be more like placeholders. Our 2 significant figures are going to be our 1 and our 2. But we have a 5 here. So we're going to end up needing to round up. So our answer is going to be 0.013. But if we end up doing the rule, remember that real weird rule, third rule that we talked about, where we said even, leave, or odd, round up? This is actually, because this 2 is even, our answer is 0.12. And that's because of this third rule of rounding up. The last one let's do is 48. 48 is 124.7. And again, we're looking for 2 significant figures rather than 3. So we don't have any zeros in this number. So our first 2 numbers, our 1 and our 2, is going to be significant. And we're working with a number that's in the hundreds. So our last number, we're going to have to put a 0 in the place for a placeholder. So we're going to end up as 1 and 2 as our significant figures, and then 0 is going to go in as a placeholder. So we're going to end up with 120 as our answer. I hope all these examples of significant figures really help clarify things in your mind when it comes to significant figures. I really encourage you to go ahead and change up the number of significant figures that you're trying to find with these same examples. We did 3 significant figures for all the examples, and we did 2 significant figures for some of the examples, but maybe do 4 significant figures, or go ahead and work all the problems trying to find 2 significant figures. Use these same problems for more practice, but if you need extra help, don't hesitate or feel free to reach out to me during my office hours or email or before or after lab time.